Probabilities using counting techniques. Using permutations. Two brothers enter a race with 5 friends. The racers draw lots to determine their starting positions. What is the probability that the older brother will start in lane 1 with his brother beside him in lane 2? So we're looking at the probability of this occurring. So we'll do the number of ways the two brothers can be organized over the number of ways 2 people can be organized out of the set. Well, the number of ways that the 2 brothers can start in lane 1 and 2 is 1 way. The number of ways the 2 brothers and the 5 friends can be organized in the 2 starting positions, number 1 and 2, would be the 7, and then order matters in this case, permutation 2, which gives us 1 over 42 for the odds of the 2 brothers starting in lane 1 and 2. So the probability of event A happening is 1 over 42, and the odds of it happening would be 1 against 41. Using combinations. A focus group of 3 members is to be randomly selected from a medical team consisting of 5 doctors and 7 technicians. What is the probability that the focus group will be comprised of doctors only? So we have 5 doctors, we have 7 techs, for a total of 12 people. The number of ways we can select 3 doctors out of 5 is 5, choose 3, and the number of ways that 3 people can be chosen from the group will be 12, choose 3. Turn that into your fraction, and that will give you 10 over 220, which will reduce to 1 over 22, and that gives you your probability. The odds in this case will be 1 against 21. Part B, what is the probability that the focus group will not be comprised of doctors only? So in Part B, we want the complement of what we found in question A, and the complement is simply 1 subtract that probability. So in this case, it's 1 subtract 1 over 22, which will be 21 22nds. And the odds in this case of this occurring is 21 against 1. Probability using the fundamental counting principle. What is the probability that 2 or more students out of a class of 24 will have the same birthday, assuming that no students were born on February 29th? Well, we have to find the event of no people having the same birthday and then subtract it. So ultimately, we're going to find the probability that we're looking for equals 1 minus its complement. So we're going to find the complement first. So the probability of the complement happening is this. The first 2 people do not have the same birthday. So there are 364 ways out of 365 days that the second person does not have the same birthday as the first. And then following that logic, the third person then has 363 days without the same birthday as the first 2 people. And the fourth person has 362 days. And this carries on until we reach the 24th person, at which point we'll be at 342 over 365. That value, by the way, is determined 365 minus the 23 other people leaves you with 342. So to figure that out, in shorthand will be 364 P23 all over 365 to the 23rd. And that will equal approximately 0.462, which means the probability of two students having the same birthday is 1 subtract the value we just found, which is not having. So therefore, the probability of two students in the class of 24 having the same birthday is 0.538, otherwise known as 53.8%. Thanks for listening.